All right, so number 11 says find the exact values for the 6 trig functions of the angle theta. Let P equal theta. So this one got me a little bit just because it had an angle labeled, but basically we ignore that because we're looking for, it said let angle P be our theta. So we want to know the 6 trig functions. So we're wanting sine, cosine, tangent, and its reciprocals, right? And so I'll write them in a minute because it just dawned on me we might have some radicals or something in here that I have to work out, which we will. So it gives me a little bit of room. All right, so what do we know about sine when we're dealing with a right triangle? Opposite over hypotenuse. Excuse me, but do I know the hypotenuse? No, so I need to go find it, don't I? So we know that a squared plus b squared equals c squared. And so when we do this, remember side C is across from the 90, which is actually probably should be labeled side N, but so we got 1 squared plus 0.7 squared equals c squared. All right, and so we get C is going to be the square root of 1.49, correct? Which we can't break down, we can't do anything to, so all right, so we know this side is the square root of 1.49. So when we fill in for sine, we know sine, you already said, was opposite over hypotenuse. And so we get, what is opposite? Over our hypotenuse we just found. Can't leave the radical on bottom. So we end up with a square root of 1.49 over 1.49. Not a big fan of this problem because you also can't leave a decimal inside the fraction, can you? So what you need to do then is remember there's a 1 right there. So take this 1 divided by 1.49. And when you do that, you should get 100 over 149, but you still have your square root of 1.49 on top. And then cosine, what is that in terms of opposite adjacent hypotenuse? Good. And so my adjacent is good over my hypotenuse. Can't have the radical on bottom. So we have 0.7 square root of 1.49 over 1.49. Again, can't have the decimals. So put that in your calculator and it tells you 70 over 149, but don't forget you have that square root on top. And then tangent, remember, is opposite over adjacent. So that's what, 1 over 0.7, which is 10 over 7. All right, so then we got to find our reciprocals. The reciprocal of sine is cosecant. Because we had to do so much work up there on sine, cosine, and well, tangent we really didn't have to. I'm just going to use what they're equal to. So cosecant is hypotenuse over opposite. So that's going to be what, the square root of 1.49 over opposite, which is 1. So square root of 1.49. Reciprocal of cosine is secant. So it's hypotenuse over adjacent. So it's the square root of 1.49 over 0.7. So let's put this in my calculator. So I get, what's that, 10 over 7. And don't forget you have that square root on top. And then the reciprocal of tangent is cotangent. And so we know that that's adjacent over opposite. So it's 0.7 over 1, which is 0.7. All right, so number 12, it says use the given trig function secant of theta equals 2 to find the requested trig function's value, tangent of 90 degrees minus theta. Well, that's one of those cofunction identities, okay? And so we know that it is equal to, what is the cofunction of tangent? Cofunction of tangent. Cotangent, right? All right, so we know it's equal to cotangent of theta. So if we can just find cotangent of theta, then we know tangent of 90 degrees minus theta. So let's work on that. So they told us that secant of theta is equal to 2. And so, I mean, it's up to you which way you use. We know we can make it a triangle. We could use x, y, and r. Or we could use, well, like I said, the triangle and use Pythagorean theorem. So which way do you want to do this? The triangle? Great. So in that case, we also know that cosine of theta is equal to the reciprocal, right? So 1/2. And so cosine is adjacent over hypotenuse. To me, it's easier to use the main 3, so that's why I went ahead and did it, though you could have done it from secant. So when we look at this triangle, this is my theta. We know our adjacent is 1, and our hypotenuse is 2.
How do you know it's a right triangle? You just like that.
Well, they're talking about, it's a good question. How do we know it's a right triangle? 2 reasons. 1, because we're in 6.1 and it dealt with right triangles. 2, because it has that cofunction identity that only works for right triangles. Okay? So good question, though. All right. Well, using the fact of adjacent, hypotenuse, and opposite, then, if we're looking for cotangent of theta, we know that that's equal to adjacent over opposite, right? So we already know adjacent, but we don't know opposite, do we? So how can we find opposite? Yeah, Pythagorean theorems. A squared plus b squared equals c squared. And so I'm just going to label that A. So we're looking for side A. So we're going to subtract the 1 and take the square root. And some of y'all might have already known what this is because it was a 1 square root of 3, 2 triangle, if you remember your 30, 60, 90s. But if not, that's okay. We found it anyways. And so now we know adjacent is 1. We know opposite is a square root of 3. And we know we can't have that radical on bottom, so we're going to rationalize that denominator. And so we get the square root of 3 over 3. Okay, on number 13, it says solve the right triangle ABC, where angle C is 90 degrees, angle A is 53 degrees, and side C is 17.2. So we're solving the triangle, so I'm going to go ahead and just set up my little chart here. And that's the way I know when it's all filled out, we've solved it, right? All right, they told me angle C was 90 degrees. They told me angle B was 53 degrees. I'm sorry, angle A is 53 degrees. And side C is 17.2. And remember, this is a right triangle, so if you need to, draw it. So what do we want to find first? Angle B? All right, how do we find angle B? 180 minus the other two angles added together? And we get? Good. So let's go find side A. How are we going to find side A? Which is across from angle A, right? So how do I find that side? What is that side to the 53 degrees that they gave me? Opposite. And they gave me the 17.2, which is what side? Hypotenuse. So opposite and hypotenuse is what trig function? So we know that sine of 53 degrees equals opposite over hypotenuse. And just multiply by the 17.2 to get it off the bottom. So side A will equal 17.2, excuse me, sine of 53 degrees, which is, okay, so A is 13.7, and they didn't have any label for our sides, right? So now we just need to find side B. How can we find side B? Well, side B is across from angle B. What is that side to my 53 degrees? Adjacent. And you already told me they gave me hypotenuse. So if I know adjacent, or I'm looking for adjacent, I know hypotenuse, what trig function is that? Cosine. Cosine of 53 degrees and equals our adjacent, which is B, over our hypotenuse, which is 17.2. So multiply by the 17.2 on both sides. And so side B equals 17.2 times cosine of 53 degrees, which is all right, and so we said we got what? 10.4? All right, so 10.4. My angles all have degrees. My sides, they did not give me labels, so there is our solution. All right, number 14 says, two friends are on opposite sides of a river. To find the width of the river, each of them hammered a stake on his bank of the river in such a way that the distance between the two stakes approximates the width of the river. One of the friends walks 190 feet away from his stake along the river and finds a line of sight from his new position to his friend's stake across the river, and the line of sight to his own stake form a 40-degree angle. How wide is the river? Yes, there is. All right, so let's picture it. Here's our river. Okay, look, it's even blue. This is a pretty river. All right. And so it says here that to find the width of the river, they each hammered a stake on the bank of the river on his bank, of a river in such a way the distance between them approximates the width. So we've got a stake over here and a stake over here, and the distance between them is going to approximate that width that we're after. One of the friends walks 190 feet away from his stake. It doesn't matter which friend, whether it's the one on the top side or the bottom side. Doesn't matter if he goes left or right. I'm just going to make him walk this way 190 feet. He finds a line of sight from his new position to his friend's stake and to his own stake forms a 90-degree angle. So when he's looking from his friend's stake to his stake, this angle is 40 degrees. How wide is the river? Well, we know it has to be straight across because the only way to find the width then would be straight across the river. So it's going to form a 90-degree angle. They gave me my angle of 40 degrees. They gave me, I'm looking for x, which is what side? Opposite of the 40 degrees. And I know the 190, which is what side to the 40 degrees? Adjacent. So if I'm looking for opposite and I know adjacent, what trig function can we use? Good. So tangent of our angle is equal to opposite over adjacent. And so x is equal to 190 times tangent of 40. All right, so what is the width of the river? What was that? 159.4 feet.